Procedure. Place a few pieces of granulated zinc in the flask. Pour about 20 ml of dilute sulphuric acid into the flask and fit the apparatus as shown in the figure. Take a conical flask with a suitable rubber stopper carrying a jet tube. Have a feel of the flask containing zinc pieces and dilute sulphuric acid. It appears warm. Perform the following test on the hydrogen gas produced in the flask. Test, experiment, observation, inference. Nature. Bring a moist blue litmus paper near the upper end of the jet tube. No change in color of litmus. Hydrogen gas is not acidic. Bring a moist red litmus paper near the upper end of the jet tube. No change in color of litmus. Hydrogen gas is not basic. Color. Observe the color of the evolved hydrogen gas. No color. Hydrogen is a colorless gas. Odor. Smell the hydrogen gas coming out of the jet tube. No odor. Hydrogen is an odorless gas. Combustion. Bring a burning candle near the open end, upper end of the jet tube. Hydrogen burns with a blue flame and popping sound. Hydrogen is a combustible gas. To confirm the presence of zinc ions in the solution at the end of the experiment, take about 2 ml of solution from the flask in a test tube. Add drop-wise sodium hydroxide solution. White precipitate once formed gets redissolved when excess of NaOH is added. The solution in the flask contains Zn2 plus ions. Observations. Thus we find that when zinc reacts with dilute sulphuric acid, two new products, zinc sulfate and hydrogen, are produced. The properties of the new products are entirely different than those of the reactants. When zinc interacts with dilute sulphuric acid, some heat is evolved. Result: the interaction between zinc and dilute sulphuric acid is a chemical change. Precautions: sulphuric acid must be handled with care. The test tube for the combustibility of hydrogen should only be shown to the students by the teacher. This test must be performed with utmost care.